Hello students, this is part 2 of writing equations for sinusoidal graphs video. Here we're going to look at few examples and practice writing the equations by finding the values of A, B, C, and D. So we're going to write one sine and one cosine equation for this given graph. First thing, as I said before, we'll make it easier if we follow kind of the steps in order. So first thing is I'm going to identify the minimum and the maximum value. And as you can see, the minimum value is -4 and the maximum value is 2. So I'm going to find the average of -4 and 2, and that gives me the value of D, which is -1. So then I'm going to draw this midline at -1 as the sinusoidal axis or the midline. Then I will use this midline and take the maximum point. I could also do the minimum, but I'm taking the maximum and get the value of A. So A in this case is 2. Now, since I want to write the sine and cosine equation, it doesn't really matter which one you write first. I think it will be easier to write a cosine equation first because the graph is at the maximum point at 0. So you will not have to use any phase shift. And I want to figure out how long is this cycle. So I'm going to take the distance between the two consecutive maximum points. So that is between 0 and pi, which gives me the value of b, the period. Period is pi, which gives me the value of b. 2 pi divided by pi is 2. So I have A, I have D, I have B. And I'm going to just go ahead and write, because I'm writing the cosine equation first, my phase shift is 0, so C is 0. My equation is just going to be y equals 2 cosine of 2x minus 1, and I'm done with the cosine equation. For the sine, I do want to start from a midline, and I could choose a point where it goes, from that point it goes up. If I don't want to use a reflection, then I'll have to start here. If I don't care about the reflection, I could start here and show reflection. So it's really your personal choice. Let's start here. My equation is going to be y equals, so for this, my phase shift is -1. That's the only difference, and it's going up, so no reflection. 2 sine of, I'm going to keep the 2 out as my b, x plus pi over 4 minus 1. If someone wants to start here, then their equation will be y equals 2 sine of 2 parentheses x minus pi over 4. Don't forget to do the reflection here, otherwise it will be a wrong equation. If you graph these on Desmos, all these different equations, you will see that you will actually just get one graph. All these equations will be just make a graph on the same graph. Okay, we'll just kind of overlap because these values calculated from these equations are going to be same. Okay, let's look at, and another thing is you could distribute the two if you wanted to. Okay, so that was an option. Let's look at another example, and I'm going to pause here and let you try to write a sine and cosine equation for this graph. Okay, so hopefully you already answered it. The min is 1 and the max is 3, so that means your D is 2. I'm going to draw this midline. And the distance from that point to the maximum is 1. And if I'm looking at the sine equation, then it's at the midline at 0, so there will be no phase shift. And one cycle for the sine has to have a max, a min, and back to the midline is 2 pi. Well, the period is 2 pi, which means the b is just going to be 1, correct? In other words, there's no stretch or shrink in the graph. So very simple sine equation is going to be y equals sine of x plus 2. And that pretty much is it. Because your graph has no stretch or shrink, your graph has Um, just a shift up by 1 unit, no physical stretch shrink, no horizontal stretch shrink, no phase shift, just a vertical shift. For the cosine equation, you could start from here, and that point is pi over 4. How I know this is because this is, sorry, not pi over 4, pi over 2, because this is pi, so this is exactly halfway through it. So my equation will be y equals sine of x minus pi over 2 plus 2. I meant to say cosine. Okay. If you do want to start from the minimum, which I don't think anyone would try to do that. The reason being is this is already simplified, so why you want to add more variations? But it's a right equation, like I could do from pi over 2 left and deflection. Okay, let's look at another example. So here again, my min is -5 and max is 1, -1. So I'm going to use those min and max to figure out the value of D. So D is -3, so that is our midline. From that, we can calculate the amplitude, which is 2. As you can see, and I put this little square here just because the amplitude is always the perpendicular distance. So this is going to be 2. And again, sine is pretty simple here. Let's figure out, because it's no phase shift, it is at the midline at 0. And one cycle is completed. Looks like in 4. So period is 4 units. So B is equal to 2 pi divide by 4, which is pi over 2. And again, no phase shift because I'm writing the sine equation first. Y equals 2 sine of pi over 2x minus 3. If I do want to write a cosine equation, I can start from here. So I'll show a phase shift to the right, and it's starting at the max, so no reflection. Again, I would keep the pi over 2, the b value out, x minus 1 minus 3. And I can distribute that pi over 2 into the x minus 1 factor if I choose to. But as it is, it's also good. So the next one is similar, and I want you to try this on your own. So I'm going to pause here. Okay. The value of maximum value is 1 and the minimum value is -5. So -5 plus 1 over 2 is -4 over 2, which is, and I can just show all the work here also. So D is -2, which again give us the value of A, amplitude is 3. If I want to start from the midline, you can just see that the graph is at the midline right here. I have to show a phase shift to the left about half. I think it's halfway between 0 and -1. So one cycle is completed right here, which if this is 6, I'm going to assume this is 5.5 approximately. So between -0.5 and 5.5, that is 6. So the period is 6. And if it's difficult for you to read, you could also go from peak to peak, right? And the distance between these two consecutive maximum values is also 6. 7 minus 1 is 6. So B is equal to 2 pi divided by 6, which is pi over 3. If I'm writing my sine equation, I have to use a phase shift to the left. So Y equals A, which is 3 sine of B, which is pi over 3, x plus half minus 2. And my cosine equation, I could start from 1, that's the maximum at 1, 3 cosine of pi over 3 in the parentheses x plus 1, sorry, x minus 1, I'm writing before thinking, minus 2. And I could also have other variations of this depending on where I'm starting, okay? But the values of, again, A, B, and D will not change uh, in the variations, also in the sine between sine and cosine. Both of these did not have any reflection because because the sine it's going up from the midline where I chose the starting point, and cosine was at the maximum. I hope this was helpful. Thank you.